could kind of say the theme of this week's papers is search. And so we have two papers that do some sort of search as a key part of what they're doing. So let's talk about them briefly. I found that the SyRust paper was sort of easier to understand, and possibly because test generation is simpler than program repair, and also I certainly don't know as much about program repair as I would like to. So let's talk about the SyRust paper. And so here the idea is that it's a search to do test generation, and they point out, well, if you just do standard straightforward test generation as you might for Java, then you run into the type system, and it turns out that most of the programs, in some sense of most, are just not going to compile, and that is really not very interesting in terms of generating tests. And so they have special rules, which then they feed to a solver, and then solutions to this problem that they pose then can be translated into valid Rust programs. And so I think it's a fairly easy to understand paper, as I said, and it seems like it solves a useful problem in terms of generating test programs for Rust. And we'll talk about what we think specifically about what this paper does and how useful it is in conversation. Yeah, it's interesting that they talk about unsafe, but that it doesn't actually come into the core of the work that we have. The core, the real challenge here is you got to deal with programs that respect the uniqueness constraints of Rust. And I also found there was a good explanation of what's going on in Rust here. Okay, so that's one paper. The other paper is about program repair, and maybe I'll have less good explanation in it, but we'll see. So I found that, okay, so it's Concolic program repair. And the issue here is that you're trying to do program repair, but the existing techniques have this problem that they might overfit to the test cases that you're using to repair, right? So in some sense, people are pretty good at overfitting, and so and algorithms are even better at overfitting. And you say, okay, please repair this program so that it conforms to the test. And so there's a couple of ways you can do that. The first way you can do that is you can delete everything except for the thing that that satisfies the test. And if you do that, then your program doesn't generalize anymore, and that's not very good. And so they totally avoid that by having their search approach in this case, which searches two spaces. It searches the space of patches, potential patches for the program, as well as the space of paths that the program runs. And so they say that by doing that, they get better generation of potential patches for their benchmarks. They emit a ranked list of potential patches, and they say, well, very often the patch that the developers did is pretty much like the patch that that we did, or is in the top 10 or something. Okay, so yeah, I mean that's, oh yeah, the other issue that I want to talk about in this paper is that, so usually program repair works with respect to a specification. In this case, or with respect to test cases which act as a specification. In this case, the program repair acts with respect to a specification that you have to present, you have to provide to the tool. And so we should talk about if we think that's a reasonable thing as well. All right, so we will meet tomorrow and talk about these two papers. See you then.